Hello everyone. So today we are going to discuss yet another interesting question. Now this time it is based on the application of Gauss law. So why I am saying this is an application of Gauss law, you will quickly understand. Here we have to find the electrostatic force exerted by a plate which is uniformly charged, and they have given the charge density of the plate as sigma. This is a square plate of side 2L, and we are seeing the center of the plate O, and at L height above O there is a point charge kept or placed with the help of some external agency obviously. So they are asking how much force this plate will exert on the charge. Now when we see such type of diagram, immediately it comes to our mind that array flux, electric flux, and flux calculation is very simple. Yes, we are going to use the concept of flux and find the force over here. Let's see how. So here, for doing so, first of all, what we can clearly say, since electrostatic forces obey Newton's law, so we can say that the electrostatic force by the plate on the charge will be simply equal and opposite. So negative of electrostatic force by the charge on the plate. Fine, we can do so. Now what we can say from here is, if we want to find the force by Q on the plate, we can take a small area anywhere. Why I am taking a small area? Because the electric field due to Q will be variable throughout the plate. So we are taking a small area dA, and it has a charge. Let's call that charge as dq. Now how to find dq? dq we can write, dq will be sigma into dA. I hope this is clear to everyone. So you can say that the field due to Q at the location of dA will be in this direction along this straight line, and the force, if I take this force as dF, we can say dF is nothing but whatever charge dq multiplied by the electric field. This electric field is due to Q. So dF is dq into E, right? Now this is the force only on this small area, but if I want to find for complete, what we have to do? We have to integrate. So when I am saying magnitude of the force by plate on Q, this will be same as magnitude of force by Q on plate, and this value we can write, it will be nothing but the integration of dQe. We have to take its magnitude. Now let's see one interesting thing over here. What is that? When we are taking this force as dF, now this force on this elementary charge dq due to this small q, this will have two components. One will be along the surface and one will be vertical, and this one is horizontal. We can easily say so, dFH and dFB. But what will happen, since the charge is symmetrically located with respect to the plate, so dFH, this value will cancel. So this cancels by symmetry. So when this cancels by symmetry, which one will remain? dFV. Now suppose this angle, if we take it as theta, so we can say dFV is nothing but dF cos theta. So when we substitute over here, what is dq? First of all, dq can be written as sigma dA. What is dFV? dFV is dF cos theta. dF was dQe, so this becomes dQe cos theta. So here we have an extra term like this. So sigma dA E cos theta integral, this will give you the force. And where is this force directed? Vertically downwards. So since this force is directed vertically downwards, so the plate will exert force on the charge q, where vertically upwards. Now we have to find the value. How to find this value? For this we will see something which I said related to Gauss law. What is that? If you take the plate which we had shown in the diagram and this charge q, we can consider a cube whose side is 2L, and the charge q will then be enclosed completely by the cube and will be at the center of the cube. So we know the flux through the plate due to q, or due to the field of q. How we define it mathematically? We say it is E dot dA, and this will be equals to what? The flux, since the charge falls at the center of the cube, so the total charge, the total flux associated with the charge q is how much? Q by epsilon naught. Each of the 6 faces of the cube will receive same flux, so flux through the plate is nothing but 1 by 6 times of total flux associated with the charge, which is this. Now what is E dot dA? Here also same way, if you take dA elementary area and this q charge, its electric field being E, and we know dA vector is always taken normal to the surface, their angle between them is theta, so E dot dA is nothing but E dA cos theta. So what we are seeing, integration E dA cos theta, integration E dA cos theta is equals to q by 6 epsilon naught. So if E dA cos theta integration is q by 6 epsilon naught, just return back and substitute this value over here. So what we can see over here, this becomes sigma. E dA cos theta we just saw was, now remove the integration also. Why to keep the integration? Sigma is a constant, sigma comes outside. Once sigma comes outside, integration E dA cos theta directly becomes q by 6 epsilon naught. So our required answer is q sigma by 6 epsilon naught. So this is going to be the force exerted by the plate on the charge or charge on the plate. I hope this is clear to all of you. So if you got this, do like and subscribe and stay tuned for further videos to come. Thank you.